Hey folks, this lesson is inverse of simple quadratic and cubic functions. So it's a little bit of review on finding the inverse of what we did, and then we're going to graph these and the inverse, and of course the line y equals x. So how do we find the inverse of simple quads and cubic functions? Okay, so here we go. So here's a many to one function if I graphed all of these points. And the reason why it's many to one is -2 gives me 4 and +2 gives me 4. -1 gives me 2 and +1 gets me 2. So that's what it means by many to one. They're going to the same one y value right here, okay? So the inverse is to switch the x's and the y. So this -2, 4 would become 4, -2, and so on, and so would all the rest of them be right there. And then if we graphed those guys, it would be that graph right there. All right, so now this graph, the blue points right there, is not a function because it fails the vertical line test. Remember, if we did the vertical line, it intersects those 2 points. So if you draw a vertical line through and it intersects your points in more than one spot, then it is not considered a function. Do you guys remember the vertical line test right there? Okay. So to restrict the domain of f of x, so that the inverse function is a function, then what we do is we just take the x values that are greater than or equal to 0. And so what happens is it takes off these guys right here. And so we're going to restrict and take away these x values that are negative right here, and just use these x values, this one, and this one. And so the inverses would be this one, and this one right here. And that is a function because it won't fail the vertical line test. Because I'm just looking at the blue points right there. And so the blue points pass the vertical line test right there, okay? So let's restrict the domain of each quadratic function and find its inverse, okay? And then graph the function and its inverse. So actually I should have put cubic functions on here also. But the quadratics, we got to restrict the inverse. We got to make x greater than or equal to 0. Okay, so this is a parabola. You remember graphing parabolas? So every x, when you plug in an x, you square it, but then you got to multiply it by a half. So 0 squared is 0. 1 squared is 1, but by times a half would be only a half, so there'll be a point right there. And so here, let me show you here. So to find the inverse, we switch the x's and the y's and then solve for the new y. I guess I'm doing that first, okay? So here's y equals 0.5x squared, or y equals 1/2 x squared. So we're going to switch the x's and the y's and make it x equals 1/2 y squared and solve for this y. So we're going to get the inverse of this equation. So multiply both sides by 2 and then square root both sides, and we get that right there. Now since we restricted it to be positive only, we don't have to worry about the plus or minus piece right there. We're just concerned about the plus piece. All right, so let's go ahead and graph. So there's our inverse function. Remember our inverse function, it says f inverse of x equals that square root of 2x right there. Okay, so let's go ahead and graph these guys. All right, so when we plug in 0, 1, 2, 2.5, I'm going to plug it in here. 0 squared times a half, and then 1 squared times a half, 2 squared times a half, 2.5 squared times a half, okay? And then over here it would be 2 times 0, and then square root, 2 times 1, and square root, 2 times 2, and square root, okay? So there's those guys, and they give me this graph right here, okay? So that would be this one right here, y equals 0.5x squared, or y equals 1/2 x squared. Okay, and then when we plug these x values into this, we get these values right here. Okay, so oops, there's the graph right there. So here we go, we're going to plug those in, and we're going to graph those points right there. So they look like that right there. Okay, now check this out. Do you remember the mirror that these guys create? It's this line always. It's a reflection. If they're inverses of each other, here the red graph is a reflection of the blue graph over this line, y equals x. So that's why we switched the x's and the y's, because it'll make a reflection over the line y equals x right there. So I'm going to use this trick for graphing purposes. So notice if I picked this point and went straight across, perpendicularly across, it would get me this point. if I chose this point and went perpendicularly across, it would get me this point, okay? They're always going to go through the same point of y equals x right there. This point would be this point right here. This blue guy would be this red guy right about there, okay? All right, so let's do that with this one right here. So y equals x squared minus 7. Okay, so x squared minus 7 means it's going to be down here at right here at negative 7. All right, so there it is. So when I taught my kids how to graph quadratics, there's the vertex right there. And then we go over 1, up 1 squared. And then we go back to the vertex, over 2, up 2 squared, which would be 4. If we went over 3, it would be up 3 squared, which would be 9. So it would be right there. So anyways, there's that graph right there, okay? And we're always on quadratics, you can't square root negative numbers, so we have to restrict it to just be positive on quadratics. Cubics, we can. All right, so now here's we're going to go ahead and get the inverse now. So here's y equals x squared minus 7. So we swap the x's and the y's. X equals y squared minus 7, and we solve for this new y. So now I'm going to go plus 7 right there and get the new y's, and then square root both sides. So we get, so here's f inverse of x equals the square root of this side right there. All right, and then how do we graph that guy? Well, we can graph the square root function, or we can just reflect that blue guy over the green line right there. So this guy right here, if I just go straight across, perpendicularly across, is going to be right there at negative 7. Okay, and this one right here is to the right 1, up 1. So this one's going to be up 1 to the right 1. So it's going to be right there. This point, if we went to the right 2, up 4, here we'd go up 2 to the right 4. Okay, so all of those points are going to be, whoops, I went a little bit too fast right there. So there it is right there. The red guy is a reflection of the blue guy over this line right here, okay? And they always go through the same spot on y equals x, okay? So you just had to know the vertex was right there, okay? All right, let's try this with a cubic one, okay? So 0.5x cubed. Okay, remember cubic functions look like this. Y equals x cubed from section 5.3. If we went over 1, it goes up 1 cubed, which is 1. If we go over 2, it goes up 2 cubed, which is 8. Here, over 1, down 1. Over 2, down 2, because negative 2 cubed is negative 8. So we made a graph and it did that. Now, this is a vertical compression, so we're going to go up half as much as this one. So we're going to go over 1, and we're not going to go up 1, we're going to go up a half. So over 1, up a half. It's going to go right there, and same on this side. So this one goes over 2, it goes up 8, so we go up half of that. So we'd still go over 2, but up only to 4 right there. Same on that side right there. So there's those points right there, and then if we graphed them, there's that right there. Okay, so now let's reflect that blue graph over this green line right there. So this point right here becomes, just goes straight across. It's going to become this point right here. Okay, this point right here is going to become this point right here. It's at the half mark right here. This point over 1, up a half. So if we go here over half, up 1, that would be that guy. This one goes over 2, up 4. So here we're just going to be doing the opposites right here. We're going to go over 4, up 2. Okay, so I'm sorry, over here. So it's going to go over 4, up 2. So this point is going to be reflected straight across right there. So there they are right there. And then go ahead and make your graph right there, and there's a reflection right there. Pretty cool, huh? All right, let's find the inverse. Okay, so now y equals this, so this is 1/2. So now I'm going to swap the x's and the y's and solve for this y. So multiply both sides by 2. You get y cubed equals 2x, and then cube root both sides. So f inverse is the cube root of 2x. So there's the inverse right there. Let's do one more. I know you guys love it. Okay, another cubic one. So it's down at -9. So this is in the form of f of x equals x minus h cubed plus k. So my 0, 0 gets moved to HK, so it's at 0, negative 9. So there it is down there. All right, looks like these are going by 2's, okay? So we're going to go over 1, up 1. We're going to go over 2, up 8, which is 2, 4, 6, 8 right there, okay? And same on the other side. So remember, that's how that graph goes. Now, I could have gone 8 here, so over 2, down 8. So there's 2, 4, 6, 8, somewhere down here. Okay, so but anyways, there's our cubic graph, something like that. Now let's reflect that over the line y equals x. Okay, so this point right here, which is at, looks like, well, this point right here is going to be at 0, negative 9. So over here we're going to be at negative 9, 0, which is right there. This point right here is at 1, negative 8. So this one's going to be at 8, negative 1 right there. And you just flip the x's and the y's of these points right there, and that'll give you those points right there. Okay, so there it is. It's a reflection right there. So this red guy is reflecting this blue guy right there. All right, let's find the inverse. So now we just do y equals x cubed minus 9. So x equals y cubed minus 9 plus 9 to both sides, cube root both sides, and so there's our inverse function right there. All right, you guys, if you are in my class, you're going to get that groovy assignment. Okay, and then, hey, the directions say confirm with composition functions. You can skip that part. Just find the inverse and just graph it when they're asked, all right? You can skip the confirming with composition parts. All right, you guys, take care.